Dear friends, in this video, I'm going to show you as to how to model the price analytics problem number 2 in the Excel environment and then obtain the solution using the solver optimization engine. This problem we have already discussed in the previous video. Anyway, it is in front of you. You can see. And the cost to produce the video game console is $250, and you need to find a price between $200 and $400, which will maximize the contribution or the profit. And you need to estimate the demand curve, obviously, otherwise you can't solve the problem. These are the facts given. So what I do now here is I have the yellow color here, and top of it I write price, which is not known. This cell will have to be found out. Cost is given per unit as $250. Profit per unit is price minus cost, which we will have to use a formula and compute. Then I need to compute the total profit by multiplying the unit profit with the quantity demanded. And we have price column, we have demand column. I have just entered these values here. And these are already in the problem. You can see. Now, what is the nature of the demand curve? In order to do that, what I do here is I highlight this, insert graphical thing in Excel and charts, and I go there for the scatter plot with the option of the line here. So the demand is on the y-axis, the quantity demanded, and the curve looks like this, corresponding to the price on the x-axis. So $200, $300, and $400, the demand is 50,000, 25,000, and 12,000 respectively. Now, what is the nature of this curve? In order to do that, I click here, add trend line. Looking at it, obviously, it is not a straight line, and therefore, I put a polynomial here of degree 2. The polynomial is very, very, very close to the curve, and it fits in. I display the equation here, which is a quadratic model, a polynomial of degree 2 here. And let me increase the font to show you what the computer does here. So this is the equation of the demand curve. Y equal to 0.6x squared minus 550x plus 136,000 is the constant. Now, these dotted lines, small lines, if they are disturbing you, you can remove them. So right click, format trend line, put here no line, it will go. Now, again, I want to show you how good this fit is. We can ask for the R squared here. R squared is what almost 1, as I told you, it fits in so well. In this particular case, it may not happen everywhere. And therefore, it's a very close fit, a quadratic function, polynomial of degree 2. So this is the demand. Now we are ready to solve the problem. So let me put here price, some trial value. Now profit I compute by the formula price minus cost. Price sell minus the cost to sell. I compute this and I get this profit. Of course, this is a trial value. Obviously, minus 249 is not acceptable. But this is the profit per unit. Now, total profit, I use a formula here, which is equal to unit contribution or profit, this cell, multiplied by, I open a bracket, 0.6 star price cell into the price cell again, minus 550 star, again the price, plus 1,36,000. I close the bracket. So I get the total profit here. Obviously, this is a trial solution, and this is not the final one. So let me just go to data solver. Let me reset all for clarity. This is the green color cell is the total profit, which will have to be maximized. So I highlight this here. This is the maximization case. So that is displayed there. And by changing the price cell, what should be the price? Then I have two constraints. The problem says the price will have to be between 200 and 400. And therefore, what I do here is the cell reference price, I put here greater than or equal to 200. Add another constraint, the price is less than or equal to 400. And by option, the computer says GRG non-linear, which is appropriate, generalized reduced gradient method, and therefore I'm ready to solve. So I click solve here. I have found the solution now. As you can see here, the optimal price is 400. Unit contribution is 150. The total profit is 18,000. Total profit is 18,000. So now what is the demand for the price 400? If you substitute in this equation, you don't have to do that. The demand will be 12,000. In other words, when I substitute here 0.6 into 400 square, minus 550 into 400 plus lakh and 36,000, it's not required. 400 is the demand. Is the price. 12,000 units is the demand. So let me color this part also for you in a different color. This is the final answer. So I put here this color. Now you can see here, optimal price is $400. Quantity demanded is 12,000. Total profit is 18 lakh dollars. This is the total profit. And the optimal price to be charged is $400. Unit contribution or profit is for 150. Total profit obtained is 18 lakh dollars. Signed, sealed, and delivered your problem in a magnificent way using the Excel solver. Thank you very much. We will see you in another video very soon. I hope you have enjoyed the session. Once again, thank you.